So, verifying trig identities. Well, how's this like a puzzle? Well, a couple of quick hints at the start to make things a little bit easier. First thing I'm going to do is I'm going to try to convert everything into sine and cosine before I start. Because what we're basically trying to do in that case is say, okay, if I'm going to be trying to reducing things, canceling things, all that stuff, it's a lot easier to do that if the things are all alike. And what you'll notice about all of these identities as we work through them is basically all of them have sine or cosine somewhere in them. So if we get all of this stuff into sine and cosine, it'll be a lot easier to find something that we can cancel, reduce, something that way. So these identities that are here, and they're things that we've seen before. Cosecant's just the inverse of sine. Secant's just the inverse or the flip of cosine. And tangent and cotangent have that same relationship. But here's what's going to be more useful to us. Typically when you see tangent or cotangent in one of your problems, this is what you're going to want to change it into. Because I'll have some of you at the start, you'll be walking up saying, okay, well I had cotangent, I put 1 over tangent, but it's not helping me. Right, because these are going to be much more useful than this would be. Or if I decided I was going to try and turn this around and say tangent is 1 over cotangent, not going to help me as much. These are the 4 that are going to help you the most. If you occasionally get one of those things in here where you see a plus or a minus, that's where these ones right underneath are going to help when we get there. But I'm even going to help you out with something else. Sometimes you may not see it in this form. It may be in a form like, well, what's sine squared theta equal? So here's how we're going to think about it. If I wanted to get sine on a side by itself right now, what would I need to do? Somebody said it, be brave enough to say it loud. Subtract cosine squared theta. So if I wanted to know what sine squared theta equaled, I would just subtract that cosine squared theta and it would go to both sides. Now again, on this first one, I'll show it out in its completeness because I know sometimes when I skip steps, some of you are like, wait a minute, what exactly, how did you make that go over there? All I'm doing is like with a regular algebra equation, if I want to solve for something, you just do the same thing to both sides. And that's where this is coming from. That may come in handy. That's why I go ahead and write it on the note sheet. So if I need to, I can do that. And the same thing is going to happen if I attempted to get cosine squared theta on a side by itself. I'd minus the sine over to the other side. So sometimes even manipulating the identities I already have can come in handy. Just something to have there, just more tools to use when I'm trying to solve the puzzle. And the same thing happens with these. They give me secant. Well, what if I want tangent on a side by itself? You'd minus the 1 over. So if I wanted tangent sometime, that would be secant squared minus 1. And there is a difference. I couldn't write 1 minus secant. That wouldn't be algebraically correct because I'm minusing the 1, okay, not the secant. So again, I'd have secant, tangent, sine, cosine. What have I got left? Cosecant. Oops, I can still get this by itself. So the same way, I could minus the 1 over. If I wanted to equal cotangent to something, who knows? You never know when a tool may come in handy. So that's why I'm going to go ahead and get all of these moved around and situated so if I need them, I'm going to have a quick reference for them. So what are we going to use all these 8 things for up here at the top? What purpose do they serve? Well, sometimes it can be something as simple as just simplifying something, almost like simplifying a fraction when we do that. Or sometimes we can verify or prove something. So what we're going to do is basically take those 8 things up here at the top, and we're going to use them to simplify some fractions. So here's how this works. Okay. First thing I see here is cotangent. We set up at the top, try to convert everything into something that has sine and cosine. Well, cotangent, that's not sine or cosine. What up top that cotangent is solved for has sine and cosine in it? Look around for cotangents. Where do you see sine and cosine with a cotangent? Yeah, I see it right here. Cotangent equals this. So I've got, okay, so that we're using x this time. That's all right. So I'm just substituting. Cotangent equals cosine over sine. I just replace it. I'm going to do the same thing with secant. So notice I don't see any pluses or minuses, so these 3 aren't going to help me. What could I use up top that might help me? You only have 5 choices. Take a chance. There's only one thing with secant. I'm being frightened. Yes, okay. The only place I see secant is where it says 1 over cosine. So I'm going to replace that with 1 over cosine. You're like, and the purpose of this is what again? Because now, like any fraction, if I see anything top to bottom or diagonally that can cancel, I can do that. And then let's see what I've got left here. 1 over sine of x. Can I simplify that at all? Do I see 1 over sine of x anywhere? I see it right there. So it would be cosecant of x, and I'm done. Now the big issue people have with simplifying, well, when am I done? Well, you're done when you can't keep flipping things around anymore. Like I wouldn't want to go from something that's a regular identity back into something that's fractional. That doesn't make sense. So whenever I'm seeing fractions and stuff still, I'm going to look. Sometimes it may have to stay in that fraction form. But I'm going to simplify as far as I can until I see something that's one of my regular ones up here, because most of these will do that. So if I do that again on the next one, okay, let's see. What can I do with cosecant? 1 over sine, because I see that over here. Then what can I turn the tangent into? Sine over cosine, because I see that right here. Most of the time you're just going to be using the ones that are up here at the top until you start seeing pluses and minuses and things. So similarly to what happened back on A, I see signs that I can wipe out. I'm left with 1 over cosine, but does that simplify into anything else? Secant. And I'm done. So it's just we're trying to get rid of the multiple terms in the fractions and get them into something that's simplified. Now, can there be twists? Of course there can be. That's how this works. So I look at the next one and I go, ooh. Here's my first issue. I see the parentheses, which means I need to multiply this. So I need to FOIL this out. So you're like, okay, that's not real exciting. So if I have to FOIL this out, I look at it and I go, okay, so first term times first term. So that would be secant squared x, just like x times x would be x squared. Secant times secant is secant squared. But then when I look further, I'm like, hey, outside would be a -1 secant, but inside would be a +1 secant. So they're going to cancel out. That's cool. And then 1 times -1 would give me a grand total of secant squared minus 1. That's what it would look like FOILed out. Now, that may come in handy here in a minute. I'm going to leave this alone for just a second. So I get that FOILed out, and then I start looking around again. Do I see secant squared x minus 1 anywhere? And again, x and theta are interchangeable, so don't think they're not identical. Yeah, because I see secant squared minus 1. Hey, so that's going to be tangent squared. Now, you're like, wait a minute, you said try to turn everything into sine and cosine. Why aren't you doing that? Well, sometimes if I start seeing things that might be able to reduce in this way when I see tangent, that can come in handy. That's sort of my backup plan to get things into sine and cosine. This is another similar situation that you may not recognize right away when you look at it this way. This is the equivalent of having something that's like x squared over x. I treat it just like I treat a variable term. So what would x squared divided by x be? Just x, because I'd subtract the exponents. Same thing here. Tangent squared over tangent is going to equal just tangent, because like anything else, it's like looking at the exponents. 2 minus 1 is 1. Bigger exponents in the numerator. I get tangent, and I'm good to go. That's what we're working towards on these. Now, I personally think simplifying is harder than verifying, which we're going to do next, because you're not positive when you're done, even though basically it'll be when we're not down to fractions or anything. At least with verifying, we're going to know where we're heading, but it works the same way as this. So if any of you have ever had to prove anything, this is our version of proofs in here. We got to show every little step that we're doing to get from the beginning to the end. So we're going to do what we call trig trades. Sounds a little more catchy. With the expressions. So we're still going to be using the stuff that we used on the top, our identities. But there's only a couple of rules. And I should have put a couple because there's only 2. You have to show every trade and every manipulation. You can't skip steps. Okay, no simplifying in your brain. And you can't touch the right side of the equation at all. So here's how this works. And we'll keep flipping back and forth to get ourselves some help here. When we see the word verify, before we do anything else on these top 4 here, I want you to put a box around the right side of your equation. We are not going to touch that. Our job is going to be to make this left side, make this left side look exactly like the right side through manipulation. You're like, oh boy. So okay, I'm going to expect to hear a lot of flipping when we're doing this, so we'll see. First job, I need to turn tangent of x into something with sine and cosine if I can. So go flipping if you need. What is tangent going to turn into? Sine over cosine. Okay, now we're getting some confidence with our statement here. I can hear some of you. This is good. Sine over cosine. What's cosecant x going to turn into? 1 over sine. Just using those top 5. Once I do that, I'm going to start to reduce. I'm like, okay, so sine and sine cancel. Gives me 1 over cosine of x. What's 1 over cosine of x equal? Secant of x, which is now the other side. I'm done. I proved it. I proved this equals that through my manipulation and my identities. That's your job when it's verified. Take what's there, switch it around into something else, and then use that to cancel. Now sometimes they look like, really? This is going to be impossible. You want me to turn this into 1? Yes. But we have some things that looks like we can kind of steal from this last one. So tangent, okay, we just got done saying that's sine over cosine. Cosecant, we just got done saying that's 1 over sine. you're like, now I'm going to turn cosine into something. Wait a minute. What are we trying to turn everything into? Sine and cosine. That's already in cosine. I'm leaving it. If it says sine or cosine already, leave it, because more than likely it's going to be in a good place for you. Because you look and you're like, hey, diagonal, they cancel. Diagonal, even though they're not right next to each other, diagonal, they cancel. 1 over 1, last I checked, equals 1. Verified. Any issues so far? Because that's what we're going to do all the way down with these. Now, sometimes is there going to be some complexity? Yeah, there's going to be some complexity. Actually, I'll warn you, this one's going to get a little interesting. You're like, okay, I don't see anything that says sine over cosecant. You're right. But you're like, well, you told us to leave sine as sine. That's also right. What's cosecant itself equal? 1 over sine of x. Okay, we're going to deal with that in a second here. And then cosine, what we said, well, if we see cosine, we're just going to leave it. You're like, how is this going to become 1? Okay, little side work here so we can see what's going on. Sine of x divided by 1 over sine of x. Okay, let's draw this in a format that might make a little more sense. Sine of x divided by 1 over sine of x. And no, you can't just cancel right off the bat, because remember, it's division. When we're dividing with fractions, what happens to the second fraction? The reciprocal. We flip it and it becomes multiplication. So this is going to equal sine squared of x. You're like, okay. So this whole thing right here equals this. You're like, how is that helping me? So now you've got sine squared of x plus cosine squared of x. So am I going to have to manipulate something again? No. Because if I flip over and look at the other side, what do I notice? Sine squared plus cosine squared equals, woohoo, 1. I'm done. It's just going to have to be getting used to saying, okay, this equals this, that works, this equals this, and you do. You just keep kind of playing with it, messing until you hit just that perfect spot. But sometimes there may be a little extra manipulating in there, but that's okay. We can make this work. But I got to show all my steps when I'm doing it. So I get to the next one, and I'm like, ugh. All right, piece by piece, we got this. Cotangent of x, what's that going to be? Flip and look if needed. Okay. Well, wait a minute. What's it? Nah, not 1 over tangent. I want something with sine and cosine. Keep looking.
Cosine over sine.
Okay, cosine over sine. Then I notice the next one is cosine, so I'm just going to leave it. But then I look at the denominator, and I go, oh. What's cosecant going to be? 1 over sine. You're like, okay, now this is getting complex. We got fraction times fraction over fraction. Take it slow. Take it in pieces. So I look and I say, okay. So if I multiply these guys together, that's going to be cosine squared x. Okay, but not x squared. We want the squared on the cosine over the sine of x over 1 over the sine of x. Again, don't let that start driving you crazy, because we're going to rewrite it horizontally in a minute, which for a lot of you would be a really good step here so you can see what's going on. So cosine squared over sine. And we just got done saying when you divide, you're actually multiplying by the reciprocal. So we're going to flip that over. Okay, so we're up here. And I'm like, oh, signs cancel out. So what's that leave me with? Well, it leaves me with cosine squared of x. You're like, well, heck, what am I supposed to do now? That's all I got left. Well, wait a minute. Let's go see what we got working here. I'm trying to get to 1 minus sine squared of x. Let's see if I can find that here. There it is. 1 minus sine squared of x. What's it equal? Cosine squared. Oh, cosine squared. Okay. So that equals 1 minus sine squared, and I'm done. So those manipulations we did before we even started are now helping me to see, oh, that's how this works. So even if I'm down to just one thing, that might be the one thing that I need actually to make this work and work this out. But anytime I see verify, I am not touching the right side. Never, 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 ever. Ever. Okay. Do I want to be brave on this one? Yes. Try it. I'll put the picture back up here momentarily so you can see the process that we're working through. But again, take a look. If it's already sine or cosine, leave it. If it isn't, manipulate it and keep manipulating. I'm going to have you do something that you haven't done before, so some of you may get to the second step and go, wait a minute, how was I supposed to know that? And we'll talk about it, but I want you to try it and kind of see how this works. Some of you may be surprised at how well you can manipulate something in mathematics, that is, versus what you may do otherwise. So play, play, play. Because we're going to discover a manipulation that you may not have even known you could do. I'll give you a hint. When you get to your cosecant squared x that you hopefully got in your first step, you're not going to be turning that back into 1 plus cotangent again. Find another place where cosecant of x is. Now, even if it's not squared, and think about how you could manipulate that into something that could be useful. If it takes a little bit of time, it does. The part that I have uncovered here, that 1 plus cotangent is cosecant. That may be the part where you said, well, wait a minute. I don't see anything else with cosecant squared. So here's where I said use something else that you see. The other thing I see with cosecant is 1 over sine. But you're like, okay, that's not the same thing though. But I can square both sides of that expression. So yes, you can take cosecant x equals 1 over x sine over x and turn it into cosecant squared equals 1 over sine squared. That's legal. It's algebraically, you're just squaring both sides. It absolutely is something that you can do. So if I can do that, if I can turn this into this, now I have sine of x times 1 over sine squared of x. And all of a sudden, it starts to become a little more clear. Oh, now I have all these sines that I can work with. Once I have everything into sine, I can go ahead and simplify my fraction by either multiplying across, or if some of you are comfortable, you could cross cancel at that point. Get rid of this one and have this, down to 1. But otherwise, what you find out at the end, it's like having x over x squared. the bigger exponents on the bottom. So that's where my sign ends up. And then I remember, oh yeah, 1 over sine x is just cosecant of x. I'm done. Took a little extra work. It took a new manipulation that I may not have thought about before, but as long as algebraically you can do it, it's legal, just like anything else in algebra would be. Adding, subtracting, multiplying, dividing, whatever you normally would do, you can do with these. So this last one then, okay, that's cosine, leave it alone. What's secant going to be? 1 over cosine, because it's its inverse. And then you're like, well, wait a minute, this last one's already sine and cosine, so I'm supposed to leave it alone, right? Yes. That we're going to leave alone for a minute. You're like, ooh, this isn't real fun. One happy thought. Inside the parentheses, I see that I'm supposed to be adding and subtracting with fractions, but they have a common denominator. So that's cool. I'm going to go ahead and turn that into one fraction. So I have 1 minus sine squared of x. Okay. Baby steps here. But then I kind of get stuck. I'm like, well, now what am I supposed to do? I don't totally see what's happening here. Well, can I turn 1 minus sine squared x into something that has to do with cosine? Because that'd be awesome. Let's see here. 1 minus sine squared. 1 minus sine squared is cosine squared. Nice. So I keep rolling along here, and I'm like, okay. That's a whole heap and a lot of cosine, Hardy. Yes, it is. But now that I have all this cosine stuff and I'm multiplying them together, I'm just going to multiply across and see what happens. Cosine squared x. Cosine times cosine is cosine squared of x. And anytime, even when you're verifying trig identities, if you're dividing something by the exact same thing, you get 1. Woo! So your task is going to be to tackle the worksheet where you're doing simplifying and verifying with identities. We're going to spend some time Monday going back over these, getting you some new ones to try with and stuff like that. And then the day after that, we'll be looking at the quiz preview, and then we'll be looking at the quiz of the stuff. And then we'll be heading towards some other stuff with the ACT and things like that.